Hello. How are you guys? Are we live yet? Let's see. Hello, everyone. How are you? Hey, how are you? Are we good? Meanwhile, I'm trying to make sure I can see everything that you guys are typing. What's this? Oh, do this thing. There we go. Are we connected yet? I'm sorry for the delay. I was just setting up all of my equipment after a long, long, long time. If you can hear me, I'm trying to figure out if the sound is working. If you can hear me, let me know. What is 2 plus 2? Aha! I see that you guys already can hear me. In that case, we're good. Well, hello everyone. Welcome back to our live solve. It's actually been a long time since I used this particular equipment and this room to run this show. So that's unfortunately why we started a little bit late. I'm Po-Shen. I'm the mathematician who's behind Live. I'm normally also a math professor at Carnegie Mellon University, and for a while I was the national coach of the International Math Olympiad team. But nowadays, what I'm most interested on is trying to help build more thoughtful people. And for that, we have this AMC 8, which is one part of thoughtfulness, which is the thinking part. Did any of you guys try my mock AMC 8? I had some fun making this mock AMC 8. Did anyone notice any theme for this particular mock AMC 8? Every year when I make a mock AMC8, I have to think about what might be the thing everyone's talking about these days. And for some reason, it seems like everyone's doing this. Something about 6 and 7. So I decided to make the whole thing themed around 6 and 7. Okay, looks like you guys like that. Well, with that, let's go ahead and get started. So I'm going to go and start from a question which was from last time. Here we go, which was done last time, and there was a little bit of an issue because the question's pretty hard. So let me go and start with that one. Just a second. And I should say, whenever we do these live solves, the real purpose is to show you how people think. So we're always intentionally bringing on our instructors from live who haven't yet done the questions yet. That's the entire point. So our hope is that if you get used to seeing how people think when they haven't seen anything before, seen the problems before, then you'll see how you think whenever you go around to solve a question yourself too. And the people we bring are actually really, really good. They have a lot of background in these mathematics competitions and so on. But it turns out that even if you're really, really good, sometimes the questions can be a little bit stumpy. We'll see. And I'm not sure if that's a word. I just made that word up. Well, with that, I want to go ahead and do this question. My understanding is from last time, this was a question that we need to pick up on. Yes, I'm looking at the notes from my team. So you guys presumably were in this. Did anyone have any thoughts on this question first? I'm actually just looking at the chat as it goes because I want to know what your thoughts were as you were looking at this question. You said it's fun. Okay. Some people have some ideas. There is a 67 inside. Okay. I see that some people were thinking about this one's actually pretty tricky. In fact, I was in fact just teaching this particular question in my class at Carnegie Mellon University last session, which was Friday. Well, let's see. So this question says you start from the origin and you take exactly 67 steps. And you want to know how many different ending locations there are. So I'm not sure how far they got on the last one, but if I go here, oops. Oh, this is interesting. The system that I use has a different slide structure than the system that our team usually uses. So in that case, I'm gonna go, I'm trying to think because my team in the past would always give me a few blank slides that I could use. I wonder if enter does it. No, it doesn't. Okay, well, in that case, I'm just gonna do the thing right on top of here. Okay. Actually, meanwhile, I'm going to ask my team if you can send me a version that has some blank slides in between. I might be able to switch to that for the subsequent ones. But in the meantime, I'll go ahead and do this one here. So if you start from 0, 0, okay, let me start by just drawing the coordinate axes. Coordinate axes look like this, okay? And the important thing is to notice that as you're taking these steps, when you take these steps, you only can go to, well, you start on places where it looks like a checkerboard pattern. I want to say that imagine there's a checkerboard pattern on the entire plane. And if you start from a particular square, imagine a chessboard actually. Maybe this is a better way to think of it. I have an idea in my head. I'm trying to communicate it to you guys. Imagine a totally different question first, which is that you're walking around on a chessboard. And on a chessboard, you're moving one square in each direction. Okay. If you think about it, you'll realize that you keep switching colors. The same thing is happening here. So if I take 67 steps, I can only end up on the positions which would correspond to a different color from the positions I started with. What do I mean? Well, if these were the coordinate axes, maybe over here, maybe that one was the blue color one. Let's pretend that way, blue color one. From there, you can go to any of these four, which are smaller green colored ones. And from there, you can go to any of the, from each of those, you can go to any of these blue colored ones, which if you look at what I'm doing here, I'm drawing what happens, all the places that you can go after 2 steps. And after 2 steps, you can also go back to the origin. So if you look at this, you realize that as you're walking around here, the positions you can go to are going to flip between being on the green spots and on the blue spots. Okay? And if I go on one more step, these what I've colored here are all the positions that I can reach after less than or equal to 2 steps. And if I want to know where I can reach after less than or equal to 3 steps, that would be all of these points too. Okay, all of those. So if you can see what's happening, the green spots and the blue spots look like they're in opposite positions on a checkerboard pattern. And this is where I can reach after at most after 3 steps, after at most 3 steps. After exactly 3 steps, the places that I can reach are the green spots here, not the blue spots. Okay? In that case, what would it look like if I wanted to take up to 67 steps? Well, let's try to solve a smaller problem and try to notice a pattern here, right? And thanks very much to everyone for typing into this chat. We have a team of moderators who's also helping to take a look at these comments and elevate some of the ones that we particularly like. Those are the ones that we put stars on. But if you can see, after 3 steps, the positions I can get to are the green ones. Let's try to solve this problem for the 3, and then we'll notice an interesting pattern. How many green dots are there? One easy way to do this is to look at how many there are in each column. And there's 1 here, there are 2 there, there are 3 there, there are 4 there. What is 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1? Anyone? Because this is how many positions I can get at the n equals 3 case. I see a lot of people are saying 16. That's correct. This is 16. 16 is an awfully nice number. Can anyone tell me anything else that's nice about the number 16? Aha, it's 4 squared. Now, if you look at this carefully, you can see why it's 4 squared. It's because there are 4 green dots over here. Okay, let me highlight them. Those are the 4 green dots. Maybe I want to do it a little bit more pretty. Let's put it like this. These are the 4 green dots, okay? 4 green dots here. And then I have another 4 green dots here. And then I have another 4 green dots here. And then I have another 4 green dots here. Aha. That's actually why it's 4 squared. So in that case, can anyone tell me what the answer would be if I take 67 steps? This is what happens if I take 3 steps. If I take 67 steps, what should we do? It should be 68 squared. That's right. So for the 67 case, I need to get 68 squared. What is 68 squared? We could calculate it ourselves, or we could look at these answer choices. There's a hint. I mean, not a hint, but there's a way to look at the answer choices and say, which one does it have to be? What do you see? I see people are typing the answers. By the way, if you have a reason, the reason's even better than the answers. We always like thinking, right? But if you look at this, some of these numbers don't really look like they could be 68 squared because I can look at the last digit, right? The last digit should end in a 4. it should be something ending in a 4. And if I look at these answers, I guess 4 to the 67 might end in a 4, but that sounds way too big. And 67 factorial, that ends in 0. So then the answer to the entire question is 4624. And that should be the answer. That is. Okay. The next thing I'm going to do is I'm going to temporarily swap my screen just for a moment because my team has very kindly sent me the updated file. So one moment, please. We're going to use the updated file because this one gives me the space for scratch work. If you're wondering why I need this space for scratch work, it's because I actually use a different system than the rest of our instructors. So we have, just a second, let me go here. Oh, there's a few steps involved in getting this file. Just a second. One moment, please. I'll be clicking on a few things while I'm getting the file. But the reason is because you might have noticed that a lot of times when we do these live solves, the people who are running the session are using some fancy equipment. Those are our live instructors. And they have a different set of equipment than I do here. I have the old school equipment. And with my old school equipment, I need to use this way. Just a second. Here we go. I'm just grabbing the file down from my team. Yeah, and I use the old school equipment, which is also unfortunately why I was a little bit late here because I was pulling everything up. Just a second. I know. I'm pulling the file down from somewhere else and I had the caps lock on. Here we go. Okay, this should work. Yeah. Thanks for your patience, guys. Now we can go on again. Okay. It seems to me that the next question we should be doing is question number 20. And let's go on. Everyone ready? Let's go. Here we are. Okay, question number 20. Let me just move this piece over here. The chat piece. Move it over here. Okay, this question is pretty cool. Looks like we got a triangle and looks like we have some curvy things. So over here, we have, yes, this one is fun. I see people commenting. So triangle ABC has this right angle. It's right here. The right angle is at vertex B. And the legs are of length AB, which is 6, and BC, which is 7. Let me just label those right now. So this is 6, and this is 7. Okay. Now we have 3 arcs, which are semicircles, and their diameters are the 3 sides of the triangle. So we have one of them, which is here. This is a this semicircle has the diameter, which is that side. This semicircle has the diameter which is the 6, and this semicircle has the diameter which is the 7. And the question is, what is the total area of this shaded region? Well, 67 is not a choice. However, the question does have a 6 and a 7, and this particular question is surprising, very surprising, because when you look at this at first, you say, which of these answers could be right? Well, surely not A, because there's no pi in there, right? So it cannot be A. And it's probably not D, because D has a pi squared. So it's got to be one of the other ones. Is it the square root 85? Maybe, we'll see. Well, anyway, let's try to figure it out. So if you want to do this, we have to first figure out the area of this curvy thing plus the area of that curvy thing. And then we probably have to subtract off the areas of this piece and this piece. Yikes. What is that? Well, when you look at this, unfortunately, it's very hard to understand what's the area of this curvy piece even, because, well, that's part of a semicircle. But then, a way to think of this is to imagine what would happen if I took the area of the first semicircle and added it to the area of the second semicircle and subtracted the area of this third semicircle. What would you get? It's pretty interesting. If you add this area and add this area and subtract that area. Well, it shouldn't be the answer. It should be too small. Okay, so let me try to write this down. I got this picture here. Okay. So what I'm asking for is, what happens if I took this area plus this area minus this area? If you imagine what you're doing, you're going to take this entire thing, take this entire thing, you'll lose this part, and you'll lose this part. So what's left over is this curvy piece plus that curvy piece. However, you got to be careful. You also are down by minus of that triangle. Did that make sense to people? Because if you imagine you took this entire lump and this entire lump, and then when you subtract off this piece, it does successfully subtract off that lump. It also successfully subtracts off that lump. So I'm left over with these two moon-shaped things. They're actually called loons. I'm left with these two loons, but I also subtracted off that triangle. Okay, so this whole thing equals this loon plus this loon minus the triangle. I'm going to pause here because it turns out that this question is very easy once we get to this point. Is this making sense to people? Because you should just imagine you started from this whole thing and then you lost this piece, and then you lost the triangle. Okay? Kind of making sense. I'm seeing people answering. That's good, right? So that's almost the answer. I have these two pieces. That's almost the answer. But there's a reason why I care about this. What is this semicircle plus that semicircle minus that semicircle? We have another very nice theorem. The other nice theorem is the Pythagorean theorem. It turns out that this is 0. This whole thing is 0 here. What? Why is it 0? Let me go to another screen. Okay, so suppose I draw you any triangle. Doesn't even matter if it's 6 and 7. If this is A, B, and C, what is the area of the semicircle on this part? Can anyone type in chat and let me know? What's the area of that semicircle? It's kind of it's a formula. It's going to be pi times r squared. I don't actually want it with the 6. I actually want it with the a. Let's do it in terms of a. So it'll be pi. It's not pi a squared actually. It's kind of yucky. It's going to be 1/2 because it's a semicircle. Okay, so I got the 1/2 from the semicircle, and then I also have pi, and I have a over 2 squared, which I'm going to call 1/8 pi times a squared. Okay with that? If that's 1/8 pi times a squared, what's the area of the semicircle down here? My semicircles don't look very circular. But this will be 1/8. Yeah, I'm sorry. Those are not the radius. Those are the diameter. Oops, not 1/2. What am I doing? Go back. 1/8 pi b squared. And the one that goes on the end, I'm gonna draw the one going the other way so it's easier to draw. But semicircles have the same area, whether it's on one side or the other. That third one has area 1/8 pi c squared. What's gonna happen if I take 1/8 pi a squared plus 1/8 pi b squared and I subtract 1/8 pi c squared? 1/8 pi a squared plus 1/8. Let me draw more clearly. I'm a bit of a perfectionist, so when things don't look too good, I like to write them again. Minus 1/8 pi c squared. What happens here? A squared plus b squared equals c squared, right? So in that case, this is just going to be 1/8 pi times a squared plus b squared minus c squared, which is 0. Okay, let's go back to the problem. Now I know this is 0. The reason that's powerful is because I care about the sum of these two loones. So if the sum of these two loones minus the triangle has an area of 0, then can someone tell me what to do next? Remember, this is a 6 and this is a 7. Aha. Yes, I see that people are already typing their ideas into the chat. Very good. Oh, in case it wasn't clear, the way to talk in this room is to send your messages to chat relay along with through the Zoom setting. So this triangle here is 1/2 times 6 times 7. That's that triangle there. And that's equal to 3 times 7, which is 21. Okay, so this part is 21. This yellow stuff is just talking about that triangle here. So that means that the sum of the loones minus 21 equals 0. So then the answer has to be 21. The sum of the two loones has to have a combined area of 21. And mysteriously, the answer with no pi is actually the answer. I want to tell you a bit of history about this question. So this question is famous. These are called the loones of, I forgot which one it was. It was they're loons of Alhazen, I think. But I mean, there's a certain problem, which is the loons of Alhazen. I actually forgot which one this was. Maybe some of you who are next to a computer can figure this out. But these are called loons, Lunes. And the reason why ancient people were trying to figure this out is because they were curious whether, if you had a circle, you could find a square for which the area of the square was the same as the area of a circle. That was called squaring the circle. Yes. And so over here, people got very excited because here there is a shape whose boundaries are curvy. So it might be possible to take a shape whose boundaries are curvy and have that the area of the curvy thing has no pi at all. Unfortunately, that's not possible. And the reason why people were curious is also because they were wondering whether pi was rational or irrational. Because if pi was a rational number, you would be able to take a curvy thing and just blow it up big enough, and well, then the area would be just an integer. In this case, the sum of the areas of this and this is actually an integer. But unfortunately, pi is irrational, so it's not possible to square the circle. But this question is a big surprise. That's why I wanted to throw it here. Okay, let's keep going. Question number 21. Oh boy, what was I doing here? So we've got a unit fraction. We've got a whole bunch of unit fractions. Unit fractions are anything which has 1 on top and some other positive integer underneath. Okay, I'm just checking to make sure I have... Oh, just a second. I'm going to communicate with my team briefly. Somebody has just asked me, can I please explain problem 18? So my understanding is last time in the live stream, we actually already did do question number 18. So unless my team updates me and says that you didn't do question 18 last time, we're not going to do 18 because we did it last time. That's why we jumped over to here. Okay. And 19, I believe, was also there last time. And somebody else made a comment that said, isn't pi pretty close to 22/7? Yes, it is. But unfortunately, it's not exactly equal to. So pi is an irrational number. Oh, wait. So people said that they skipped question 18 last time? Now I'm slightly confused because one of my team members told me that you did do it last time. Let me quickly double check if that's what they told me. I'm looking because of course I can do any questions here that were not done last. Oh, they didn't question it, didn't finish 18? Okay, then let's do 18. I'm looking at what's happening here. Okay, but let's do 18 unless people tell me. So by the way, I'll tell my team I'm currently in the live stream channel. So if there is more stuff to tell me, just let me know. Oh, wait, but these slides don't have 18. Okay, well I'll tell you what. These slides actually don't have 18, so we won't be doing question number 18 this time. At least immediately off of this. Let's keep going. We might be able to do question 18 at the very end of the live solve, only because the slide deck that I have here does not have actually question 18 on it anymore. Let's keep going. Question number 21. All right. So this question also has some relationship to historical math, by the way. There is something called Egyptian fractions, and that is fractions for which. Oh yes, you want to move the chat? I can do that. Thanks for asking that question. The only thing that is covering, let me just pull the chat down for a moment. What it's covering right now is just the fact that we're going to be able to write 6/7 as 1 over a number plus 1 over twice of the number plus 1 over a different number plus 1 over twice of the different number. And the A is less than B. Well, I chose that because A is before B in the alphabet. Okay, and the question is, what is the second number, the 2B? And this particular question here, I guess I can do, yeah, you can see what's going on here. I'm going to put the chat back up because this is actually just asking for something of that format. Let me leave the chat like this. Okay, so we're looking for a way to express 6/7 in this format. The Egyptian fractions concept, by the way, is that every single positive rational number can always be written as a sum of unit fractions. It's pretty interesting. It's a pretty interesting fact. And it's not a unique expression. It's not a unique way of expressing. There's not always a unique way of express. Let me take that back. That's not what I mean at all. There's always a way of expressing a positive rational number as a sum of unit fractions. But there are often many different ways of expressing that same thing. Actually, there are always infinitely many ways of expressing that same thing. And this particular question is talking about one way of expressing 6/7. So we're trying to find a way to write 6/7 as 1 over A plus 1 over twice A plus 1 over B plus 1 over 2B. And this is possible with the A and B being positive integers where A is less than B. Putting the chat back here now. Okay? This question, and my team has just told me that last time Sam and Eli did do question 18 and 19, so we're not going to go back to those. So back to this thing here. How could we use this particular format? The hint is before diving in and trying to do something with all of these A's and B's, it's useful to notice that we can at least try to simplify some of this first. I have 1 over A plus 1 over 2A, 1 over B plus 1 over 2B. So let's first at least combine them. So if I do that, this becomes all over 2A. I get 2 plus 1 over 2B, all over 2B, 2 plus 1. Okay, I'm sorry that the B's look kind of like 6s, but we don't, with the 6 is up there. There's no 26 in this problem, okay? So if I have this, if I continue, this is 3 over 2A plus 3 over 2B. That's equal to 6 over 7. Can anyone suggest a good step to take at this point? If you see 3 over 2 and 3 over 2, it's a good idea to multiply both sides. I see someone already typed this. Multiply both sides by 2/3. So at this point, let's multiply both sides by 2/3. If I do that, multiply both sides by 2/3, then I get, what is 2/3 times 6/7? Oh, the 3 and the 6 cancel and leave a 2. So this is equal to 4 over 7. And that's supposed to be 1 over A plus 1 over B. How could I do this? Let's go back to the question. I need to find out the way where the largest denominator is as small as possible. What could I do? Well, if I have 4/7, I kind of feel like taking 1/2 out right away. So The reason is because if I have 4/7, 4/7 is bigger than half. So I can take 1/2. If 4/7 was less than 1/2, I could not take 1/2. What would happen if I took 1/2? I'm curious. What if A was 2? That's a question mark. I don't know yet. Let's see. What is 4/7 minus 1/2? Over 14, I have an 8 minus 7. Oh, that's a unit fraction. Okay, that's good. So that means that I could make B 14. Okay, so B could be 14. The thing I need to do, just to be careful, is that this question here said there's a way to do this where the largest denominator is as small as possible. So I am curious if it's possible to make this with B less than 14. But if I look at these fractions, I cannot do A equals 1 because that would be 1 over 1 is too big already. What if A was 1/3? I don't think that would work. The reason is because if I did A equals 1/3, then let me write it this way. I'll write an inequality for you. 1 over A plus 1 over B. If A was 1/3, then this would be less than 1/3 plus 1/3. Can anyone tell me why I wrote less than? What did I just use here? I'm actually trying to prove that you can't make the B smaller than 14. Yes, thank you. Kyle just said that A has to be less than B. So the reason is because if A was 3, B is even more than 3. So this would be 1/3 plus 1/4 or smaller. And 1/3 plus 1/3, that's equal to 2/3. And how does 2/3 compare to 4/7? Oh, wait, this is not useful. I actually should write less than or equal to 1/4. Let me take that back. Let me go back here. I'll write 1/4 and I'll write less than or equal to. Here we've just used the fact that, here we've just used the fact that B happens to be bigger than A. Okay, so this is going to give me over 12, it's 7/12. How does 7/12? This is still annoying. Okay, it's still annoying, but I think I'll probably have to go down to 1/5. But actually, I see. So this is actually not going to be that useful. If I go this way, if I use 1/3 plus 1/4, and I get 7/12, I want to show you how I'm thinking through this. How does 7/12 compare to 4/7? Someone's saying this is just guess and check. Not exactly. I'm actually trying to give you an inequality proof, right? But unfortunately, 7/12 I think is, wait, let me compare. How does that compare with 4 over 7? 7 times 7 is 49, so it goes that way. 7 times 7 is 49, 12 times 4 is 48. This is not useful. Because what I would like to get is I would like to get that the 1 over A plus 1 over B is now forced to be too small. So that's not useful. So instead, I should actually still check the case. What if A equals 3? Okay, so if A equals 3, I need to try 4/7 minus 1/3. When I said we have to try the case A equals 3, it's because I don't want to go and try 1/3 plus 1/5, 1/3 plus 1/6, and so on. So let's just go and do this. If I take it over 21, then I have a 12 minus 7. 5 over 21. Yuck! That's not a unit fraction, so that won't work. It cannot be 1/3. I think that at 1/4 we're already good, right? So then the next thing is if I have that, yeah, it is true. If A was at least 4, then what I would get is that 1 over A plus 1 over B is at most 1/4 plus 1/4. Okay, this will work because it is actually less than 1/4 plus 1/4. Let's do that because last time we were just talking about that. So it's less than 1/4 plus 1/4, which is 1/2. And how does 1/2 compare to 4/7? This will work. How does 1/2 compare to 4/7? It is less than 4/7. So that's how you know you cannot have anything with A at least 4. In fact, what this shows is something a little bit stronger, which is that if I have a less than b, there's only one way to express 4/7 as 1 over a plus 1 over b. And that one way is 1/2 plus 1 over 14. I'm trying to show you all of these details and all of this proof stuff because the important part about doing all of these problems is not just getting the answer, but it's also discussing all of this logic. Somebody asked, how did I get to the 1/2? The way I got to the 1/2 is because I cannot do 1 over 1. That's too big. 1 over 2 is the next one. The 1 over 3 doesn't give me a nice unit fraction left over. And the 1 over 4, it turns out that 1 over 4 plus whatever else the next thing is, you're dead. It's not going to be bigger. It's not going to be big enough. It's going to be too small. So this has just, what you see on this screen here, has just completely shown that the best possible answer is for b equal to 14. And so the answer to the whole question is 14, right? No, I'm a mean guy. When I made these answer choices, I put 14 there to trip you up. Sorry, guys. Because the question actually asks for what is the value of what's under the channel. Oh, no. I moved me. Don't move me. Just a second. Here we go. What is the value of 2b? 2b. Okay, I apologize if you ended up getting the question wrong because I was just mean, but 2b is 28. Okay, all right, sneaky. Yes, unfortunately, I'm not the only one that's mean. The people who write these problems are mean. No, they're not. They're really nice people. They want to help you learn, but they want to put answer choices that will catch when you made a mistake. Okay, let's keep going. Next question. What is this? And meanwhile, I'm going to check how we're doing on the time. We're good. Okay, yes, because I'm willing to be here until 8:30 my local time. So we got time. That's actually also why I'm intentionally being slow. I would rather have more people understand than less people understand. Okay, sounds good. Oh, wow. A question with a lot of empty space. What is the smallest area of a polygon whose perimeter is an integer, which contains an inscribed circle, tangent to every side, of radius 1? Okay, first of all, what does that even mean? Let me show you an example of a case where there's a polygon which has every side tangent to an inscribed circle. What's the easiest polygon to draw that would have this property? What do you guys think? I see some people said triangle, but I think square is easier. Let me give you a tip. If you're ever trying to draw a polygon with an inscribed circle, the secret is you draw the circle first. Then you draw the polygon. Look at that. Isn't this beautiful? Imagine if I drew the polygon first. Good luck drawing that circle inside. Okay, right. I like how people seem to like this approach. Right, so this is possible, okay? And over here, the circle has radius of 1. All right, circle has radius of 1. And this polygon has an integer perimeter. What is the perimeter of this polygon, guys? So I have radius is 1. Oh, wait. Yes, the perimeter is an integer, and we're double checking because I want to make sure the thing I drew happens to satisfy these properties. Thanks, guys. The perimeter happens to be 8. I think it happens to be 8. It's 2, 2, 2, and 2. The perimeter is 8. Okay, and what's the area? Well, the area of a square, well, that's not too hard. That's 2 times 2, that's 4. Interesting. Let's try another one. Now I will attempt to draw your triangle thing. Let's see. So, as usual, circle first. Oh, won't fit. Let's do a circle over here. Like my circle. And then I'll draw this triangle. I wonder if that triangle even does have... I'm not sure that triangle... Actually, I'm not sure that triangle is going to have an area which is an integer, guys. This could be annoying. Let's see. So if that is a 1 here, all right. Does anyone know? I just wanted to get you guys some practice. This doesn't happen to be the way to solve the problem anyway. But how would I figure out the perimeter of that triangle? I actually tell you that perimeter is not an integer. So use the centroid. That is one way. That's a fancy method. This point here is 1/3 of the way up. This is called the centroid, which is where all of the medians intersect. This is an equilateral triangle, so it's just the center, okay? There's an easier way to do this, which is to use the fact that there's a 30, 60, 90 triangle. See that thing there? That's a 30, 60, 90 triangle. Thank you. I see some people commented that already. If you have a 30, 60, 90 triangle, if that part's 1, what's this part? Some very terrible number, square root of 3. Honestly, square root of 3 is not that bad. It's quite a nice number, but unfortunately, it's not rational. And so if this piece is square root of 3, what's the perimeter? Oh no. The perimeter is 6 of them, right? 6 square root of 3. I'm still going to do this on purpose, though, because I'm going to go somewhere with this. All right, so if the perimeter is 6 root 3, how could I find the area? I know this is not going to count, but I want you to notice something interesting. What's the area? Well, there are a couple of ways to do this. If I wanted to find the area, I could actually get the whole height. Okay? To get the whole height, how would I do that? Well, this side is twice the square root of 3. And there's actually a 30, 60, 90 triangle here. This is square root 3. Can anyone tell me what the height is? This is 2 root 3. This is root 3. The height is root 3 times 3. Sorry, root 3 times root 3, which is 3. So what is the area? The area is 1/2 times the base times the height. Oh, fun trick. Whenever I see a triangle like this, if I see half the base already here, I just write half the base. That's the square root 3 times the height. Not 2. 3 root 3. Does anyone see an interesting pattern here about perimeter area and perimeter area? It looks like the perimeter is twice the area. And why is that? Actually, it turns out it's true because this is always true. If I have any polygon, let me go and take another, well, I'll leave it here so you can still see. If I take any polygon, any circle with radius 1, and then I take a polygon around it. Here I'll draw like it's not even a regular hexagon. It's just something like this. What did I do? Oh, there we go. This will do the job. Okay, I just drew this. All right. Suppose I drew this. It turns out that I can cut my polygon's area into lots of triangles. This is a formula that people often learn in geometry class, but I like to show you the proof. I just cut it into lots of little triangles, okay? The nice thing about this circle, this the inscribed circle here, is that every one of these heights in each of these triangles, I know. Let me go and label the bases with something. Let's suppose that this base is A, and this is B, and this is C, and this is D, and this is E. Those could be horrible numbers. But the area of this triangle whose base is A, can anyone tell me the height? Actually, now I'm going to call the height R, even though R is 1. Okay, the height is R. But we're going to go and get a nice formula that you can use all the time. So if the height is R and this side is A, well, the area of that triangle is 1/2 base times height, 1/2 AR. Oh, what's going to happen to the area of this triangle? 1/2 B times R. And then this triangle is 1/2 C times R, and so on. Well, in that case, what's the total area? The 1/2 times the R factors out, and you add up A plus B plus C plus D plus E. What is that? What's the significance of A plus B plus C plus D plus E? Well, that's the perimeter. So this area is always equal to 1/2 times the perimeter times the in-circle's radius. This formula only works if it happens to be inscribed around a circle. Most polygons in the world cannot be inscribed around circles. Like, I'll just show you one. Here's a polygon which does not inscribe around a circle. Good luck getting a circle to fit in there. Ouch. Didn't work. Okay, so that doesn't work. So in general, this formula only works if you are able to actually get, if you actually have a polygon with a circle inside it. In that case, how do I do this problem? It looks like I have an area and I have a perimeter. The perimeter is an integer, and the area is going to be half of that integer. You see a lot of things here that have something to do with pi. What could I do? I need to have what can anyone tell me anything that has to be true about the area of the polygon? Let's go over here. So I've got my circle. I've got a polygon around it. I'm writing dot 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 because I don't want to tell you how the rest of the polygon goes. I have the area of the polygon. Let's write more cleanly. Area of polygon. Can anyone tell me anything that must be true about the area of the polygon? Given that it has a circle of radius 1 inside. It has to be bigger than the area of the circle. What's the area of the circle? Pi r squared. So the area of the polygon has to be bigger than pi. Okay, this is pi. But the area is also half of the perimeter because we got that before, right? So the area, 1/2 of the perimeter. What do you know about the perimeter? The problem said that the perimeter has to be an integer, right? So if the perimeter is an integer, could the perimeter be 6? No, 6 is not going to work. So if it's not 6, what else could I do? Aha, so it has to be 7, right? So because well, I don't know if it has to be 7 yet, but it maybe could be 7. 8, we already know how to do 8, right? We know how to do it where the perimeter is 8. It's right here. This is the case where the perimeter is 8. So if, just if, I could do this with a perimeter of 7, that would give me the answer. Okay, let me write that down. So if it's possible to have perimeter equal to 7, then you get area equals half of 7, which is 3.5. Okay? And then that would be the answer to the question because I cannot get perimeter equals to 6. Is it possible for the perimeter to be 7? This is a philosophical question. Well, it's not. It's actually a mathematical question. And the answer is yes. But why I say it's a philosophical question is it's interesting to think about how you can make the perimeter become 7. What's actually the smallest that the perimeter could ever be? This is an interesting question on its own. What's the smallest the perimeter could ever be if it was not, if it did not have to be an integer? I see someone said 2 pi, I think. There's a reason why. It's because the area is half times the perimeter, okay? So half times the perimeter is bigger than pi. Do you see that? Half perimeter is bigger than pi. So perimeter is always bigger than 2 pi. And in fact, in some sense, if I could make just this thing be a polygon where somehow infinitely many sides or something, I would get 2 pi, right? That's what the Greeks were thinking. So really what we're looking at here is that as you get closer and closer and closer to the approximation of the circle's perimeter by a polygon, that will get closer and closer to 6.28. If I knew more digits of pi, I could tell you more digits than that. But you can keep making this smaller and smaller and smaller and getting down to 6.28. So we saw a case where the perimeter was 8. And you can keep shrinking this. If you want to know how this shrinking thing could potentially work, one way to think of it is that if you, let me put it this way, if you have any kind of a polygon around here, I can always continuously adjust the adjust the polygon and change the area continuously. Continuously is saying that if I keep moving it, if I move it smoothly, then the perimeter also moves smoothly. It's not going to jump over anything. And so if I started with something with a whole lot of sides that was very, very close to the 6.28, one way you could think of moving that perimeter to move from 6.28 out to 7 is that you can actually remove sides. Let me give you an example. So I'm giving you a lot of proofs in today's session, okay? But imagine I have this particular shape here. There's a way I could make it so that the number of sides decreases. And the way you do that is you can move the tangent points closer together. In fact, actually, if I have a polygon around a circle, the polygon is entirely determined by the positions of these points of tangency. Okay? So if I have some points of tangency and I start moving the 2 points of tangency together, do you know what's going to happen to the number of sides of the polygon? It's pretty interesting. Well, of course, while they're moving, the number of sides of the polygon stays the same. But the moment the 2 points touch each other, the number of sides of the polygon actually decreases by 1. So actually the way I'm doing this, as I'm saying, suppose you start with a polygon whose perimeter is around 6.28. It probably has like 10 million sides or something like that. A whole lot of sides. And then I take any of the 2 sides which are next to each other, and I take those tangency points and I mush them together. If you can, let's imagine this one mushing up to there. If you imagine what happens as this one mushes up to there, let me draw the next side just for fun. Suppose I've got this other side here, okay? As you can see, the polygon is determined by these points of tangency. Looks something like this, okay? And if I push this one over to there, what ends up happening, actually I don't like what I just drew there. Let me just draw it like this, okay? If I push it, this was here, this was here. Now that point is really, really close. This point is still here. These are tangencies. I don't know if you can see this, but the angle between those two gets closer and closer to 180 degrees. And so if I push them completely together, in fact, it disappears. Disappears in the sense that it becomes one side instead of 2. So I'm showing you how you can actually take a many-sided polygon and start pushing these points of tangency together, merging them together to reduce the number of sides of your polygon. You could actually reduce the number of sides of the polygon all the way down to 3 sides. If you have a 3 sides, in fact, the smallest perimeter you can get turns out to be that 6√3, which we had before. 6√3 is pretty big. It's definitely bigger than the 7 that we had. So this is a way of explaining why you must be able to, somewhere along the way, have gotten a perimeter of exactly 7. And that would give you an answer of 3.5 because you get half of the perimeter as the area. Okay, so that's why it's 3.5. Any questions? I hope this made sense. I see somebody said you love math. That's good. So do I. Okay. So when I was making these questions, I was always, oh, what am I drinking? I'm just drinking water. But so with all of these questions, I'm always trying to do something which will make you learn as well. I think that the most useful kind of a math contest problem is one where you'll end up learning some math, not just one where you do some problem. The water is very good. Thank you. Okay, let's keep going. Too many words. Who wrote these problems anyway? Why are there so many words? I guess that was me. Okay, so a bag contains 5 identical balls labeled 1, 2, 3, 4, and 5. Alice picks one of them uniformly at random and puts it back in. Then Bob picks an identical ball labeled, Bob adds an identical ball labeled 6 to the bag. Alice picks uniformly at random again and puts the ball back in. Then Bob adds another ball named 7, and Alice repeats. What's the probability that Alice's 3 picks sum to an odd number? Oh boy. So this question here, if I remember correctly, I made these questions a while ago, but if I remember correctly, this question actually has a nice trick to break the to deal with the symmetry. So if you look at this, what's happening is that the first bag has 1, 2, 3, 4, 5. Okay, so there's a 1. Oops, wrong type. There's a 1, 2, 3, 4, 5. Alice gets one of those. Then Alice is going to get one of these. 1, 2, 3, 4, 5, 6. And then Alice is going to get one of these. 1, 2, 3, 4, 5, 6, 7. Okay? And the question is, what is the probability that Alice's 3 picks add up to an odd number? It turns out that this bag in the middle is one that makes it so we don't have to do that much work. Because, you see, even though Alice first picks from the green numbers, and then picks from the blue numbers, and then picks from the purple numbers, it's the same answer as if Alice first picked from the green, then picked from the purple, and finally picked from the blue. Those are the same, okay? And by the way, if you just did this problem out, you would find an answer that would make you start kicking yourself and wondering if there's an easier way. I'm showing you the easier way right here, okay? So I could do this particular order. Now there's something very interesting about having the third pick come from 1, 2, 3, 4, 5, 6. I care about odds and evens. Can anyone observe anything interesting about the blue bag? 1, 2, 3, 4, 5, 6, about odds and evens. Casework is a way of solving this problem, but this problem has something which is really good, which is not casework. There's exactly half of the numbers which are odd and even in the second batch. I guess I'm labeling the odd ones with green for some reason, and labeling the even ones with yellow. Why not? Okay. What does that mean? Just going to make sure that good. So I have something over here I'm using to communicate with my team, and I want to make sure I don't lose battery on that thing. Okay, so there's exactly a half chance on the pick number 3 of getting an odd or even. 1/2 chance odd, 1/2 even. Now, those are balanced. Remember I said you first pick from the green 1, 2, 3, 4, 5, then you pick from the purple 1, 2, 3, 4, 5, 6, 7. Well, you'll get something, okay? Let's suppose that after 1 and 2, you got, hey, someone give me any number that you can get from 1 and 2. I'm not going to do all the cases. I'm just trying to say, just give me some number that you could get. I'm saying the sum of 1 plus 2. Yeah, somebody said maybe 9. 9 seems reasonable. Suppose you got 9. Now, suppose you got 9. And then in option number 3, there's a half chance odd, half chance even. Can anyone tell me what's the chance that you end up with, what do I care about? Well, I care about an odd number. If I got 9, how do I get an odd number in the end? What would I need to get an odd number in the end from option 3, from step 3? Step 3 would have to give me an even number, will give me a sum of odd number. Oh, what's the chance of that? The chance of that is 1/2. Probability 1/2. So I'm saying if I got a 9, the chance that I get an odd at the end is probability 1/2. Wait a second. What if instead of getting a 9, what if suppose after this I got a 10? 10 is also possible. How would I get a total sum of an odd? What would I need now? Well, now I need to get an odd number. What's the chance of that? Oh, this is a nasty problem, isn't it? Or not nasty, this is a beautiful problem. The chance of getting an odd number in the stage 3 is also 1/2. Wait a second. What does that mean the answer is? Notice, by the way, I'm saying the third option is the second is actually the second bag? The answer is just 1/2. It's because it turns out that no matter what happens from the first bag from the 1, 2, 3, 4, 5 bag and the 1, 2, 3, 4, 5, 6, 7 bag, there's always a 1/2 chance that the 1, 2, 3, 4, 5, 6 bag flips either flips or keeps the same evenness or oddness, and therefore there's a 1/2 chance of getting a final answer which is odd. And so the answer to the entire question is just 1/2. Somebody asked what happened to the stars. What happens to the stars here? I'm going to update the algorithm soon, but normally after 10 minutes, if you haven't gotten another star, then the star count you have expires. So just keep trying to make good comments, and then your star count will also keep on staying and keep on going up. But I'll also update the software soon to make it so that you just keep your stars for 90 minutes. The the original idea was to make it so that everyone would stay involved and keep suggesting ideas. So, okay, but this question's amazing. The answer is just 1/2. And of course, there are other ways to do the question, like absolute brute force using all the casework. But I made the question on purpose to teach you something. Unfortunately, if you say give me stars, you might get the opposite of stars. Let's keep going. What's next? Oh, this one. This one's pretty cool. Actually, they're all pretty cool. When I made these questions, I was always thinking, what do I want to teach you? Well, we got some points. They're midpoints of stuff. So let me go over here. I'll just move this slightly out of the way just so you can read the question first. We have a triangle, equilateral triangle. And we have some points D, E, and F. D is the midpoint of AE. E is the midpoint of BF. And F is the midpoint of CD. And the question is, what fraction of the entire area is shaded? Well, I mean, I know what answer we hope is the answer, right? But it can't be that. Because does it look like 6/7? It looks way too small. It's not 6/7. Oh, is it an equilateral triangle? That is a good question. The answer is, it doesn't matter. So this particular question, it doesn't actually matter whether it's equilateral or not. Let me see if my team gave me a nice picture. They did. Here's a nice picture. So with this nice picture, I want to show you can do some interesting calculations with areas. The first thing is it turns out you can compare the area of this shaded triangle with the area, of this shaded triangle. Really? If I want to compare areas of triangles, what kind of formulas should I use? I'm doing an AMC 8, so I guess the only formula we really know is 1/2 base times height, right? So half base times height. What's a good choice for base? This? Maybe. Or over here, what base could I use? This? Maybe. Well, there is a convenient base choice. There's a base choice where the two bases are the same. Can anyone tell me what's a good base for the green thing? Yes. What's a good base for the green thing? Given that I want to compare them. AD! I like it. You guys said AD. So let's see. What do I use? Let's use this color. You see that? Not really. Let's make it this way. This base. AD, that base. Why did I choose that base? Well, if I'm looking at this equilateral triangle, DEF, what's a good base for that? Well, they're all the same length, but there's a convenient way to think of it as, let's take this base, DE. They have the same base. How do their heights compare? Oh, if someone's wondering why your comment's not showing, it's because there's a lot of people all suggesting comments. So that's good. And we only have one comment every second or so, which gets here. The moderators are also picking a few to also elevate there. So it's just because there's a lot of people commenting, but keep trying to comment good ideas and it'll increase the chance that yours pops into here. But so there's something nice here. If these two are the same base, I want to compare heights. The height of green triangle is the height that goes all the way up to there. This height. Maybe I'll try to draw it. Let's do that. Extend this side. Can I get a height? Is that really a right angle? Doesn't feel like it should be. So I'll just draw it like this. It might be a right angle, it might not, but I feel like it probably shouldn't be. Oh, no, wait, is it? Hmm, I think it is. Okay, so it actually is a right angle. That doesn't really matter. Um, okay, so it doesn't actually matter whether it goes down to E. Why did I'm just geeking out right now thinking about this. Because if I look at what's happening here, I'm looking at this triangle. This is an equilateral triangle, and then I have another copy over there, another copy of this side. Sorry, copy means I've got this length and I got another copy to that length. And actually, if you think about a 30, 60, 90 triangle, this is what happens. I have a ratio of 2 is to 1 is to square root of 3. I have 60, 60, 60 here. This is 120 degrees, and this is 30, and that is 30. So, okay, it's nice. There's a whole bunch of 30, 60, 90 triangles. But this problem, it wouldn't be important whether or not that height happens to touch at E. Because somebody asked me before, what if the triangle is not equilateral? The same logic would actually work. All that matters is I'm dropping a height down from C, and it touches this line somewhere. It happens to touch it at E, but that's not the most important thing. Well, that's for the green triangle. I'm also going to drop a height down from F. How do those heights compare? I'm going to redraw those triangles. So I have here D, F, and C. Okay. And I have the line that goes through D. And what I want to emphasize is I just care about, is that a right angle? That doesn't look like a straight line. I have this, and I have this. Can anyone tell me how those two heights compare? Aha, it's 1/2. The reason it's 1/2 is because each of these are the same. I have similar triangles. So this is 1/2 of that. So that height is 1/2 of that. Ah, so that tells me that the height ratio is times 2 and the bases are the same. So what does that tell me about the areas? So now I know that the green area is equal to twice the white area. Wait a second. If that was the green area, what about each of these other triangles outside? See, I got this white area here. And then I got this, which is twice it. That's twice it, and that's twice it. So if I think about it, if I just wrote down what the multiplier is, this is times 2, this is times 2, and down here is also times 2. Let me temporarily move the chat out of the way. So altogether, well, over here, this is times 1. Sorry, it's hard to read. This is times 1. I wrote into the middle there. So altogether, I have 7 parts. If I have 7 parts, and one of the 7 parts is shaded, what's the answer? It's 1/7. So it's not quite 6/7. It's the complement of that. I could have asked the other question, which is what is the fraction which is not shaded? And the answer to that would actually be 6/7. Somebody just asked, if this since this argument works for most triangles, can we just assume it's equilateral? Well, it turns out that any problem which is of this form, which is about fractions of areas, and the only things that it tells you are ratios along sides, it turns out the answer is the same whether it's equilateral or not equilateral. The reason is because you can actually take any triangle, and if you imagine that it was drawn on some kind of paper, if the paper allows you to do, not paper, rubber. Imagine it's drawn on rubber. A rubber sheet, that's actually what I want. If you have it drawn on a rubber sheets are interesting because you can do stuff like this, stretch. If you do a stretch, it turns out that if I had 2 points and a point in the middle, which was a midpoint, after stretching, it would still look the same. I'll get just kind of stretched that way. I can also stretch rubber sheets that way. I can also take rubber sheets and do this. This is a shear transform. I actually don't mean paper. I mean specifically rubber. I mean like a flat rubber sheet. If you imagine a flat rubber sheet, you can do stuff like this. You can do stuff like this too. And as you do all of those things, everything which was a line actually always stays a line. Everything which was a circle gets messed up, turns into some kind of a strange ellipse. And if I have areas, fractions, if I'm comparing areas by fractions, actually those fractions, the ratios between areas also stay the same. So, but that's a more sophisticated topic. That's actually closer to a subject called linear algebra. But yes, rubber is better than paper. You can imagine things on rubber. It's quite interesting. With that, I'm going to go on to the last question. Oh boy, what's this? How many ways? How many ways are there to take exactly 8 steps, starting from 0, 0, and end up back in the same place, where each step is of length 1, and either up, down, left, or right? Hmm. So this question, it turns out to be number 25 because it's kind of scary. It's not really that scary. There's different ways to go about doing this. One way is through tons and tons of casework. How could we do that? Maybe let me just try to. I have 15 minutes, so I want to show you how it's possible to do this question in a way where you can just you kind of brute force with some casework. If I've got some ups, downs, lefts, or rights, one way to think of it is how many of the moves are horizontal versus how many of them are vertical. Can I do this with 1 horizontal move and 7 vertical moves? No, I see someone says no with lots of O's. Oh, let me put the chat back here. So the reason I can't do this with 1 horizontal and 7 verticals is because I need to end up back at 0, 0. So I must have an even number of horizontals and verticals. So let's go and start doing some casework just for fun. Suppose the number of horizontal is 0. 0 horizontal, 8 vertical. How many ways can I do this? This is just the number of ways I rearrange a bunch of letters. If I have 8 verticals, the verticals are U's and D's. So I just need to rearrange 4 U's, that looks like a W, and 4 D's. And someone told me that's 8, choose 4. We will soon have 4 letters playing around, so I'll just do it the more basic way, which is this is 8 factorial, 8 factorial over 4 factorial, 4 factorial. Oh, that's not very readable. 4 factorial, 4 factorial, right? And I got that because there's 8 ways to rearrange 8 things, 8 permutations, divided by 4 ways to rearrange the U's, 4 ways to rearrange the D's, actually 4 factorial, sorry. 8 factorial ways to rearrange all of them, divided by 4 factorial ways to rearrange the U's, and 4 factorial ways to rearrange the D's. And what is this? This is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. Usually I actually don't write out all of it because I will actually just know that I'm going to knock out the 4, 3, 2, 1. So I'll just do 8, 7, 6, 5 over 4, 3, 2, 1. That's these two, okay? But I just wrote the whole thing out here because my goal with this live solve is to be as understandable to as many people as possible. So let's keep going. How do I cancel? 4, 2 cancels the 8, I guess. 3 cancels the 6, leaves a 2. Oh, that's a nice number. Can anyone tell me what this is? That's 70. Okay. Now I have another case, which is 2 horizontal, 6 vertical. Now what am I rearranging? I'm going to rearrange a left, a right, and then up, 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 down, down, down. Make sense to people? So now that one is going to be 8 factorial over the left and right. There's only one of them, so I don't need to divide by any overcounting. I have a 3 factorial, 3 factorial. Okay, so that's, now we're going to do the shortcut. I'll do 8 times 7 times 6 times 5 times 4. The 3 factorial, it will cancel out the rest of them. Well, one of the 3 factorials cancel the rest of them. Oh, why did I write 6? I'm skipping a step. 3 times 2 times 1. Okay, but that's 6. Whoop. Oh, What is this? What's the fastest way to multiply these numbers? So I can do it by 8 times 7 is 56 times 20. 56 times 2 is 112, I think. So it's 1120. And I see from the chat some people agree, so I hope it's right. Okay, that's 1120. Next, what if it's 4 horizontal, 4 vertical? Now I rearrange left, left, right, right, up, up, down, down. Okay, what's this? This is going to be 8 factorial over 2 factorial, 2 factorial, 2 factorial, 2 factorial. This looks like it could be a quite large number. This will be 8 times 7 times 6 times 5 times 4 times 3 times 2. I'll do the whole thing over there, and I'll write 2, 2, 2, 2 down here. Cancel time. I guess I can take 8 out, and let's take a 2 out. Let's use a different color. Oh no. What's this? I guess I can do 5 times 4 is giving me a 20. And I have a 7, 6, and 3. What's that? 7, 6, and 3. 6 times 3 is 18. So I have 18 times 7. And I'll have to, then I have to times the 2. So I'll do 18 times 14. Ooh, let me tell you something you can do. 18 times 14. There's a trick. 18 times 14 is 16 plus 2 times 16 minus 2. I'm sorry I wrote it this way, but this is 16 plus 2 times 16 minus 2. That's a difference of squares. So that's equal to 16 squared minus 2 squared. 16 squared is 256, I think, if I still remember. It's been a long time since I did this kind of stuff. But 16 squared is 256, minus 4 is 252. Okay. And there should be a 0 at the end. So this should be 2520. There's a 0 at the end because there was a 20. There's a 5 times 4. Okay, 2520. All right. How about if I have 6 horizontal, 2 vertical? Do I have to do this again? Hopefully not. Hopefully we can just use something we did before. And yes, there is a faster way. But I just want to show you the answer first. So how do I do that? I should get another number which we had before, right? Because if it's 6 horizontal, 2 vertical, shouldn't I get the same as with 2 horizontal, 6 vertical? It's just doing this. I don't know if this made sense. Okay, I'll show you the faster way. Don't worry. Okay, so 1120. So this is 1120. And then we have also 8 horizontal, not 2, 0 vertical. That gives me 70. So now I need to add the numbers. What is 70? Plus 1120 plus 2520 plus 1120 plus 70. All right, fine. How do I do this? I'm trying to find a place to do this where I won't collide. I'll add the 1120 and the 70. That's 1190. 1190 times 2 is 2380. That's 1190 times 2 plus 2520 is, whoa, 4900. Really? Let me try to write this nicer. 4900. So that's telling me the answer to the question is this beautiful number 4900. 4900 happens to be, can you tell me anything nice about 4900? Yeah, somebody said it's 70 squared. Whenever I look at numbers, if they happen to be a square, I think maybe there's something going on. So it's 70 squared. Is there any other way that we could get this answer as a square? Turns out there is. Actually, do you see a 70 somewhere else here? There's actually a 70 in this problem. 70 happens to also be 8 choose 4. So the answer is 8 choose 4 squared. But why? So it turns out this question has a very interesting alternative interpretation, okay? So you start from the origin and you take 8 steps, up, down, left, or right. So let me just show you what that looks like. So you start from the origin. The origin's here. Here's the origin. And I'm going to take 8 steps up, down, left, or right. This is up. This is down. This is left. And this is right. Who likes my picture? No, this is horrible. What kind of picture is this? Well, it actually makes sense, right? Who agrees with me that the picture is pretty good now? You just have to do this, and it makes your head hurt. But this is the same problem. Do you agree that if I just do this problem where I move up, down, left, or right 8 times, like this, then, that's exactly the same thing. Okay? What's the value of that? That's telling me that the answer is exactly the same. Okay, this is the brilliance of this. Brilliance doesn't mean I was brilliant. This is just a famous problem, okay? So the brilliance of this is the answer is exactly the same as if the steps are not up, down, left, and right, but as if the steps are in the, what did I just do there? I forgot to turn palm rejection onto this screen. The steps are either +1, +1, or -1, -1, or -1, +1, or +1, -1. Do you see what I just did there? Why did I write +1, +1? What does that mean? +1, +1 is the new up. -1, -1 is the new down. -1, +1 is the new left. +1, -1 is the new right. Okay. Wait. Suppose you forgot the original problem, and you just do this purple problem. If you do the purple problem, what is happening to your x coordinate in every single step? This is like really slick, okay? So if I'm doing this purple problem, then each step, your x, can anyone tell me what's going to happen in each step? Yes, I see somebody already wrote. In each step, your x changes by plus or -1. Always. So normally, if you do the up, down, left, right in the normal way, your x might change and it might not change. Okay, might change and it might not change. And the problem is then maybe the y changes. And then we have all these cases of how many horizontal, how many vertical. In this alternative interpretation, the x always changes. And it changes by +1 or -1. How about the y? Well, same thing. And y. So that actually means that you can break this problem into 2 independent parts. What happened to the x? What happened to the y? Okay? So let me give an example. Suppose you had a sequence that was doing, how do I think of this? Yeah, let's do it this way. I'm trying to see where I have enough space. Suppose I had left, left, up, down, right, up, left, down. Is that good? I think that's okay. That's 8 steps. I think that ends up back at the origin, right? Because I have 2 lefts. No. What the heck happened? This is bad. Help. Maybe I need to have a right. I need another right. And I need a down. There we go. There we go. Okay. Yes. So now I have an equal number of lefts and rights. I have an equal number of ups and downs, and I think it's okay. All right. I want to think about what happened to the x and to the y. If I did a left first, can anyone tell me what happened to the x and what happened to the y? I have to remember. Left means x goes down by 1 and y goes up. Is this making sense? I wrote minus and plus. That's what the left is. And then I can do the same with the next one, a minus and a plus. What about the up? The up is the plus and plus. And the down is minus and minus. Right? Right is going to be plus and minus. And up I just did with a plus and plus. A right is a plus and a minus. And a down is a minus and a minus. Why did I do this? I did this because it turns out that if you take any sequence of pluses and minuses, which balances out for the x, and any sequence of pluses and minuses, which balances out for the y, that converts into a sequence of lefts, rights, ups, and downs. Is this making sense to you guys? I just showed you how to go from lefts, rights, ups, and downs into two sequences. But it turns out that if you took any two sequences, you can interpret that as lefts, rights, ups, and downs. This is super cool. Okay? These are independent. What the x is doing and what the y is doing is independent. In the sense that if I chose a different pattern, I'll show you, I'll demonstrate. Let's choose a different pattern. As long as I get balancing happening on the x sequence and balancing also happening on the y sequence, I will get back to where I started. Well, that makes sense because I'll just be taking these kinds of steps and I get back to where I started, which is equivalent to turning your head like this or something like that. Okay? So let me just show you. Suppose I have another sequence that balances. I'm just going to change that plus minus into a minus plus. That was supposed to be a plus. If I had minus plus instead, what changes is these are not R and D anymore. Can anyone tell me what they are instead? Not R and D. Instead, I have a minus minus. Minus minus is a D. And then an R. So there's actually a bijection. There's a perfect one-to-one correspondence between how many different patterns of plus minus can I write for the x, which are 8 long and balance out, and the same for the y. Every such pair gives me one of these things, and vice versa. So the answer is just how many ways can I do balanced plus and minuses with 8 long squared? Can anyone tell me how many ways to do that? The number of ways to balance the plus and minuses is equal to 8 choose 4. That was the 8 factorial over 4 factorial 4 factorial, which was 70. And this number is also 70. And so the answer to the question is, as somebody just said, oh my God, right? Like it's 70 times 70, it's 4,900. This is crazy. So it turns out that for this question, the ups, down, lefts, rights, just turn your head and then you're good. Well, with that, we're basically at the end of this live solve. I will say if you like this kind of learning style, we actually run an entire bunch of classes. And our classes actually are enrolling literally right now. I think we just started one session this last week, and we have our entire next season starting next month. If you see the way that I taught this, I intentionally didn't really prepare. Of course, I wrote the problems, but I don't want to remember how to do it straight and just tell you how to do it straight. That's not fun. It's only good if you learn by you generating your own ideas. And it's also best if the teacher is somebody who thinks on their feet. You also see that we have this chat relay. The entire point is, I think, in any classroom, you should be generating ideas like crazy, and you should be saying them. So I was actually the one who wrote most of the code for this chat relay. What we did is we wanted to make sure that while we were having class, you guys could have a productive conversation, and literally every time you think of an idea, you could say something about it. That's how our classes are running. Somebody just asked how you find out about these classes. Our website is live.poshenlo.com. My name is Po-Shen Lo. If you just go look for us on the internet, if you search for live math classes, you probably will find them too, because that happens to be, oh, you guys like it, right? That happens to be the easiest way to find our classes. It's live math classes. But anyway, if you look for my name on the internet, you'll also find these. Our classes are normally taught actually by, I will appear in them, but they're mainly taught by some even more interesting people with much better technology. I'm using technology which is like 6 years old right here in the studio right here. But they're usually taught by really incredible high school students who we bring on specifically because we actually want you to not only learn math, but we also are hoping that you can see a very sunny type of personality. I happen to think that it's really important to be good at math, but also kind of friendly, like not just kind of, but very friendly. I hope that all of you guys have that future as well. Okay. I actually am happy to stick around for 5 more minutes. Do people have any random questions? If you have random questions about anything, I'm happy to answer a little bit. But then I have to go because I have a meeting with our high school students. The math is over. If you want to do anything else, go ahead. How to make a cheeseburger. I think you get a burger, you get cheese, and you get bun. Don't forget the ketchup. Okay. How old am I? Uh, I forgot. I think I'm 43 now. That should be about right. Okay. I am not Rat Chile. I'm sorry. Rat Chile is pretty funny though. That's the heart of the system we've got here. Explosion.exe. I didn't know that you guys still did that kind of stuff. What other things do you have here? Some tips for the upcoming AMC. Be careful of the tricky things. You know, like sometimes the answer choices have the wrong answers as answer choices. So be very cautious of that. But in general, whenever you're working on these questions, when you're preparing, prepare by thinking. That's why we ran this live stream this way. Okay, what else? Other random questions which are appearing here. Let me just do this. I want to be able to see all of your questions coming in. So, oh, I know what I'm going to do. How to not waste time on the AMC? Well, oh, I'm sorry, raising hands won't work because I actually don't have audio. I'm running all of this from some super old system. So I'm afraid I'm not able to actually hear anything that you say if you do that. But how to not waste time on the AMC? I'll just say try to. Oh, good. Somebody has my team is now helping to send the questions over to me directly. This helps. So yeah, just how to not waste time on the AMC. It is useful to be able to focus so that you don't get distracted in some strange way of worrying all the time. But in general, focusing is the way to go, and ultimately use it for learning. So I hope that you use the AMC for learning, doing stuff like this. Get a good score, whatever score you can get. Good for you. Okay, but do the learning. Other questions. People ask me, what do I eat for breakfast? I had oatmeal this morning. So honestly, whatever I eat for breakfast is what happens to be there. I happen to be home, so my wife made some nice oatmeal. So that was breakfast. But sometimes when I'm outside, sometimes there's something there, sometimes there's nothing there, sometimes there's some bananas, other stuff. Are there any more mock exams that we have? Yeah, we have quite a few of them actually. If you go to our live.poshenlo.com, you will be able to find we have a previous website called the Daily Challenge with Po-Shen, and that or Daily Challenge by Po-Shen, something like that. And if you go there, we have a whole bunch of mock exams that you could do. Practice books for AMC. I actually don't think you need them. I think that, well, first of all, with all the old problems, if you go to our website, the live site, if you go to the past contests, you'll find out that we have a lot of old AMC 8 problems and solutions. So I think you really just need the old problems. And if you want to have like a class, strong recommendation, take classes that will make you think, sort of like what we were doing here. Do I like water? Yes. How to get on the donor roll? I think you mean the honor roll. The donor roll is also very easy to get onto, by the way. You donate money to the Mathematical Association of America, then they'll send you a thank you letter. But how to get on the honor roll? You score some points. I think it's something like that. To be honest, I never paid attention to how many points because that's not what we're aiming for. What we're aiming for is for people to learn how to think and to come up with ideas and to like it. Okay, other things. If you don't know how to do a problem on AMC 8 and you're low on time, what's the best answer choice to pick? I actually would recommend not guessing because the interesting thing is to get points based on you actually solving the problem. I guess if you guess, you might have a probabilistic chance of getting some more points. I just choose C. I don't know, I just made that up. Okay. I honestly am most interested in people getting points for learning, not just like getting points for getting points. Okay. Somebody asked to please explain. Oh, where are we? Where are we? Here we go. Yeah, somebody said the previous year tests are helpful. Oh, glad you like that. Best memory in math. I just like I like thinking about problems. I don't like remembering things exactly. So I'm the kind of guy who does a bunch of problems and doesn't remember exactly how to do them. I don't remember how to do the ones I just did. In fact, as you can see, I came up with the problems. I didn't remember all the details. It's most fun to come up with your own ideas. What formulas should you learn? The ones that you end up coming across quite often whenever you do these problems. So don't focus on learning problems. Don't focus on learning formulas. Focus on doing interesting problems. Please tell me if you like bacon. I find bacon to be a little bit too greasy, to be perfectly honest. So I'm not a huge fan of bacon. Sorry, guys. Okay, what else do we have here? Is AOPS good for preparing? I think there's lots of different ways to prepare. AOPS happens to be a source of preparation. We also happen to have a source of preparation too. I just like to say, go and try all the different things and see what works best for you. You might uh, you might be seeing us soon. Where do I live? Well, just Google for that. You'll probably find out. Kind of scary. But I live in Pittsburgh, Pennsylvania. Did I write the exam when I was in eighth grade? No, I did not, actually. I never even heard of AMC 8 when I was in eighth grade. I did something called math counts instead. So I spent lots of time doing that thing. But ultimately, I think that anything which gives you a source of interesting questions is good. Okay, what's my proudest moment in math competitions? I think for me, probably it was, honestly, I think I never quite thought of myself as great. I also never quite would win first place. I just always enjoyed going there and seeing all of these interesting people. So I don't really think about that. In fact, the word proud is not a word I like. So I'm not sure I want to answer that one so well because I don't think back about that as much. Hmm. Oh, do you like chocolate? Does it help you before the competitions? My math teacher recommended it. My only advice there is if you take food supplements, try them out first. Don't just do it on the day of the competition. I did once try taking sugary caffeinated drinks because I was at the National Math Olympiad training camp and there was a Mountain Dew machine. Well, there was a machine with soda. And I remember reading that Mountain Dew has tons of sugar and caffeine. So I said, maybe I'll try this. I think it decreased my scores. So be careful what you're doing. What inspired me to teach math? Well, I just like teaching people how to think, and I find that math is a good source of thinking material. If you look at my website poshenlo.com, you'll see that actually now I think about a lot more things besides math. Does the quadratic formula appear on AMC 8? I think they try to avoid using it. The most beautiful equation in math, just Google for that. You'll find something with e pi I 1 and 0 and a video. Okay, how much time should you spend on the last questions? Well, whatever time you've got. All the questions are worth the same value. So go bulldoze through the questions, and when you get to the last ones, those are the hardest ones. That's somehow a weird characteristic of all of these contests. The hardest questions are worth the same value as the easiest questions. Hmm. When I was young, did I do math bowl? We didn't have a math bowl, unfortunately, but we had some local math competition in Baraboo, Wisconsin, which was something like a math bowl, and I did that one. Okay. Is there a new probability course coming out soon? Not super soon, because honestly, if you look at my website right now, what I'm trying to figure out is how to save the world from AI. I'll be working on that first. Maybe someday I'll put out the probability course too. What are the most often questions on AMC8? Combinatorics, algebra, number theory, geometry. Well, the most common questions. Hey, where'd my screen go? Oh, I know what I'll do. I'll just change this up. So the most common questions are actually about pre-algebra and maybe a little bit about algebra too, about algebra as well. Here we go. Now you can see how bad my hair is. Let's keep going. Oh, when's the game coming out? That's actually something I'm literally working on. Unfortunately, our team was a little bit slower because our team consists of students and students got busy. But then the good news is there's a new product on the market. It's called Claude Code. If anyone's ever heard of that, that's called using AI to write your computer software. So actually, we now have a lot more software engineers on our team. They are called Claude, and Claude. So the game's going to come out soon. I've actually myself been working on it because even I can do crazy software engineering now using these AI tools. That is also why what I'm working on now is how to attempt to save the world from AI because I don't know what's going to happen to everyone. Okay, right. Hmm, what else do I have here? Is Chat Relay a real person? Well, sorry to burst the bubble, but no. Why is my hair sticking up? Okay. Can I say 6'7"? I don't know, 6'7"? Chess club? Cool. Chess is fun. I just wasn't very good at it. How do you feel about question randomization? Do you mean like on everyone's different exam, they get random questions? Sounds fine. I think that would be cool. Advice and math and future. Oh, how much money do I get per day? That's a good question. I don't know. Uh, Honestly, that's not a question I think about. my style is like someone else once taught me. They said that the way you make sure you have enough money is you just make sure you have at least $1 more than you spend. That's roughly how I live. So yeah, I actually don't know how much money I get per day, but I'll tell you that's not what I'm optimizing for. But that's also because I happen to think that the world is much more interesting than money. Hmm. Tell me your secret math Po-Shen low. Uh, there's no secret. Just think. Ooh. What is the Po-Shen low game? Well, unfortunately, I don't know if the website's up. Is it up? Game.poshenlow.com. Does it load? No, it doesn't load yet. So we are making a game, a math game. It'll be fun. We'll tell everyone about it. Oh yeah, sign up for our mailing list. If you sign up for our mailing list, we'll tell you whenever all this stuff is out. How do you sign up for the mailing list? I think if you go to poshenlow.com and then you scroll to the bottom, maybe that's how it works. Is that true? Poshenlow.com. Is this true? Scroll to the bottom. Hmm. Yeah, if you scroll to the bottom, there's like a contact, and you click on the contact, and then you can sign up for the email newsletter. And whenever that comes, we'll tell you. What's your shoe size? Well, I just bought some new shoes, so I happen to be, I think, 7 US. I had to buy new shoes because I was traveling around the world, and somewhere in Rome, my shoes got a hole in them. But then the next week I was in Africa, so I couldn't find anywhere to buy shoes in Rwanda or Ethiopia. And then I ended up buying shoes in Dubai. I guess that's what you do in Dubai. You buy stuff. Oh, maybe that's why it's called Dubai. Oh, that was such a bad joke. Anyway, yeah. So I bought shoes in Dubai. They were 50% off. Okay. All right. Do I like AI? I think that AI is going to be a big problem for everyone. But I find that AI is pretty good if you want to get stuff done. So I have been using that. What sites have I made in my career? If you go to my website, poshenlo.com, you'll see a bunch of different things linked from there. That's the easiest way to answer that question. I mean, I would love to answer more of it, but if you go to my website, you'll see a bunch of different things that I've made. Do I support AI? There's nothing we can do about it, unfortunately. What did I think of this year's AMC 10? I'm actually not entirely sure. The reason is because I was busy working on the AI related stuff. What do I think about Khan Academy for learning? I think that Sal Khan did a great service to the world by making Khan Academy. I happen to think that the interesting things to do are harder though. So if you're listening to this live stream, you probably are better suited for harder stuff. So we made all of this other harder stuff that hopefully will fit you better. If you check my website, you'll find. Do I have lessons for AMC 1012 math counts? Yes, those are our live math classes. So if you search Google for live math classes, you'll find us live by Po-Shen Low. Sing the Pi song. I actually don't know what is the Pi song. Maybe someone else will have to sing it. How would you know when to skip an AMC 8 problem because they mixed it up because of cheating? What does that mean? Oh, are you saying that maybe they changed the order so like a hard problem comes earlier? I'm roughly trying to understand your question. Maybe that's what you mean. I would just say I would try pretty hard to try to solve the questions, but if it does seem like it's really wacky, okay, then I guess I'd have to skip it. What's the most dangerous aspect of AI in your opinion? It's that I don't know what's going to happen to all the people. Like, are people going to have something interesting to do? That's a question. Then there's another question of, will it try to take over the world? Probably not. But will other people try to use it to take over the world? Probably yes. So we need some good people. Honestly, if you go to my website, you'll see what I'm talking about now is how to build a more thoughtful world. I'm much more interested in finding a way to get lots and lots of people who actually care about making other people's lives better and also really like thinking. I think that these are the best people in the world. I hope that you are among these group too. And if all of these people get to know each other, well, maybe, just maybe, we'll have some hope against bad guy using AI to try to take over the world. Okay, I'm gonna run until like another 1 minute or so until 2050. 2050 is because I'm on East Coast time. Can you tell us some leaks for your game? We don't have it, but game.poshenlo.com should go live soon. I'll tell my team to hopefully put that up soon. Oh boy. What should you bring to the AMC? Your brain and probably some kind of a pencil. What is my GPA? Well, that's not the most important question. My GPA was relatively high, and in retrospect, maybe I should have spent time doing other things instead. So there are lots of different ways to use your time. If you could remember only one formula and anything else that you could use yet to prove, and what would you pick? That's a hard question. I would actually just try to remember the basic facts and then get really good at proving things. So that's actually how I roughly work. I don't really memorize formulas. How much did you buy in Dubai? I just bought a pair of shoes. What is the hardest and easiest math competition? The hardest math competition, hmm, is to try to come up with some new research. Like that's in some sense a competition too. That's pretty hard. The easiest math competition, uh, I don't know. Maybe some kind of mental math thing. I'm just making up some stuff. Okay, let's keep going. Do I play any sports? The sport I play is called catch the plane because they're calling the plane is boarding, last call. Sometimes they say Po-Shen low, where are you? And I need to run and get to the airplane. Okay, what is my favorite hobby? Meeting people. And unfortunately, I have to call it. I have to call it the end now because I have another call I have to have with our instructors. As I mentioned, we have this program where we have the live classes. We also have wonderful instructors who are actually trying to make the world a better place. So I have to go and join them. Not have to. I want to go and join them because this is our way of contributing to other things. So very nice to get to know all you guys a little bit through all of this. Hopefully you had some fun. I certainly did. And happy 6-7 to you, I guess. Bye bye.